Again, good afternoon, everyone. This is Kishore Boyala-Kuntla, Vice President, Products and Marketing here at RIZE. Some of you know me from before. I was with SolidWorks. I was VP of Product Management there and with RIZE now. So today it's my pleasure to take you through some of what I'm seeing in the industry today. Likewise, some best practices based on what I have seen some users do. And then finally, we'll wrap it up with some of the benefits of RIZE and the printers we have and how they could help you with your innovation process. So let's get started. So additive manufacturing, it is what I've seen in my career. It is enabling a design manufacturing revolution for many reasons, and RIZE is at the center of it. There are a few trends that are happening around us. One is mass customization. We see that every day with products that are customized to a user need or to user preferences. The other part that we are seeing is because of additive manufacturing, a lot more people are able to start new products because the investment necessary to do manufacture or create parts is much lower than any time before. Anyone can now spend $35,000, $40,000, get a high quality production 3D printer from RIZE and basically start making parts for end use or for functional prototyping and go from there. What additive manufacturing is also doing, unlike any time in our history, is helping customers and users accelerate time to market. And the way it's happening today is users create different prototypes, and now very quickly, while the prototypes are being built, you can actually 3D print them and basically validate your designs and go from there. The last thing that additive manufacturing is enabling in the marketplace is design without limitations. For example, here you see a part designed for additive subtractive manufacturing and the same design for basically with generative shapes, a stronger, lighter, better functioning parts. So not only is part performance and value is happening, part consolidation is happening as well. We have seen some very good examples of several part assemblies consolidated into 2 or 3 different parts. And because of that, even reducing the overall assembly and part size with better functioning and better functionality. We are also seeing additive manufacturing actually in our customer base, where spare part delivery is happening as well. And spare parts tend to be, for example, in one customer case, products that they have designed 15, 20 years ago that are not in standard production. Something is coming back and they need to create that part. They're taking full advantage of additive manufacturing. They're also reducing inventory, and we know inventory is very expensive. There were some metrics I saw where having one part as part of inventory can cost a company $10,000 a year to maintain it as part of SKU, as well as to keep it as part of inventory management systems. So additive manufacturing enables cost reductions and high efficiency for both spare part delivery, the speed of delivery, as well as reducing inventory and the amount of inventory that a company has to maintain to service their customers. And likewise, it helps reduce material costs as well, because in additive manufacturing, you're only using the amount of material necessary. That includes supports, and once supports are thrown away, the part is ready to go. Just one thing as to what's happening in the industry. Users are creating products of the future with variants. I know one company that used to create one of a kind, and next year they're going to do 22 because that's their go-to-market strategy. We talked about generative, and likewise now you can have smart IoT AI kind of products as well. The manufacturing change is now parts are being manufactured at the point of consumption, and with personalization n equal to 1, supply chain disruption and collaborative, and we already talked about it. And I think you would be very interested. There's just one more slide after this, and then we'll get to the best practices. Talking about trends, what we are seeing is the yellow is in 2017 and the blue 2022. More and more, customers are saying that they are going to create functional parts, not just for prototyping. And for production flexibility, tooling, and spare part management, all of which speaks to the need for functional parts and are a growing priority. So you can see yourself a few years from now and including today, accelerating product development, creating niche products, increasing production flexibility, enabling co-creation. And surprisingly, what we are finding is 3D printing is enabling better collaboration between engineering teams and at multiple departments, because now both teams at different places are seeing the exact same model when the collaborative discussions are going on. We are seeing many, many examples of reducing tooling investments, the demo product expenses, including spare part management and other. And you see, with 2022, more and more 3D printing moving into production flexibility. Now let's talk about best practices. One of the things that every user faces when they are 3D printing parts is part orientation, because the part orientation impacts many things. It impacts cost, printability, as well as part quality. So one of the things to take into account when orienting the part is it printable? Where are the overhangs? How are the overhangs? Surface finish. So sometimes if you orient the part a different way, you might have to remove supports from areas that are critical to you, leaving surface marks and thereby compromising the functionality of the part. So you want to orient it in such a way you have high surface finishes in areas that are necessary. The supports. Anytime you have supports, obviously it takes time to print. There's a material cost and there is a time cost. And at the end, the part orientation directly impacts time to part. So when we talk about time to part, we are now talking about going from your design all the way to part in your hand that you can use it for production purposes or whatever it is. In other words, pre-processing of the part, and then printing the part, and then finally post-processing where you're removing the support. So part orientation is one of the things that all additive manufacturing users think about and basically spend time or at least look at different options where it makes sense. I can only speak to RIZE software, so bear with me on that. So when you have RIZE software, what happens is, depending on the orientation of the part, it will give you two things. One is time and filament usage. And filament usage directly represents the cost. Obviously, the more filament you use, the more expensive it is, the print is, and the time to print, in other words, how long it takes to print. The part you are seeing here is basically a buckle that goes into any number of things, whether it's your backpack or other use cases. And you see here, because of the buckle is stood vertically, the supports are created on this part because the buckle has an overhang and in the center pieces as well, which means two things. There's time. Anytime you have to print more material, it takes longer time, and obviously more filament usage. And then the more supports you have, the more post-processing that you have to do because it takes time to remove that support. Inside RIZE, with one click, what you can do is orient it differently. And now what you have here is the same buckle flat on the table, and all you have is supports in the bottom. And now you see that the print estimate for this is 1 hour and 36 minutes. Filament usage is 14.8 grams, what was before 2 hours, 11 minutes, and 13.9 grams. And here is the trade-off that you have to do, which is, okay, is time more important? Sometimes there's a very small increase in filament that's only less than a gram there. So you might want to say, I want it faster. And also what you want to consider is when you remove the filaments, where are these surface marks, if there are any that are coming. Just a note, one of the things RIZE does is we have something called releasing. And when we print the part, we put the releasing in such a way, the post-processing happens in very little or no time. You just peel the supports off and your part is ready to go. So please think about it as you do 3D printing. If I were you, I would actually orient the part 3 or 4 different directions. And in RIZE software and probably in other softwares, very quickly you will know how long it takes to print, as well as the amount of material usage, and then you can make an informed decision as to what is the best way to go. And also in RIZE software, there is a methodology where it actually next, it actually works in multiple ways and go from there. And one last thing before I go, where you place the part on the bed becomes key as well. I always tell people place it in the middle as much as possible or to the back, because obviously you have much better thermal control, which means you have much better parts coming out of the printer. Now, I have one use case that really I was amazed when I saw this, and I was like, wow, you can do something like this. And it has to do with manufacturing seals and gaskets. And many times you have seals that are for custom use. You have seals that are in low production. The number of seals you produce are probably only 50 or 60 or 100, depending on the number of parts you ship. And probably these are today very expensive for you because you have your end manufacturer creating a mold that using to create this low volume, high mix of seals for you. And then finally, these are functional parts and they need to work. And what I've seen, one of the users do inside RIZE is basically, and this is an end use part. And I believe the customer told us this costs them like 30x. In other words, 1/5 to the cost that they were paying for a manufacturer for a seal like this. So how do you do something like this in RIZE? Two things. Number one, I hope you see that I can actually print QR codes as well as part numbers or anything on RIZE printer. And one of the things we have is an ability to do something called marking ink. So now you can actually serial control the molds that you're creating. You can actually put part numbers. You can put QR codes where you can actually see which year, when was this mold or a part manufactured, what assembly was this manufactured for, and how many seals were created before you stored it in the shelf. And then you can also note after how many seals you generate that you need to create a new mold, because after some time you might have to redo this for much better part quality. So all of that information you can create with RIZE and putting these part numbers in there. So how do you do this? Number one, it's very simple. You can actually create the mold inside your favorite CAD system, and then once you are done, you can bring the STL or directly from inside the CAD system into RIZE. And once you are done, you place it to the command, hit go. It's an industrial printer. The print will be done. And once that's done, it's very simple. You just screw them together and you inject in this case, urethane that is actually moldable at low temperatures. And once you seal the urethane, you let it set. Depending on different parts, the setting time might be very different. And you just remove that particular seal. And the nice thing about this is RIZE has a very special material called Rizium, and it has some very special material properties. One, the material has very low moisture absorption. What this means is you have minimum material management. You get the material from RIZE, you leave it off, 6 months, 1 year later, you can use it. There's no moisture absorption, you're ready to go. It also has something called low surface energy. And what this allows to do is that to release this urethane from inside this mold, you don't need to use any release agents. It just comes off, it almost peels off. You can just pull it out and you're ready to go. The other thing is this material is stronger than ABS and stronger than polypropylene. So it has much higher, and I will show you Rizium in the material scale in just a bit. It has the other very interesting about RIZE and Rizium properties. This is isometric in the Z direction. In other words, you get very high strength in Z, even though we are actually putting one layer at a time. It has marking capabilities, which allows you to serial control the parts that you create. And obviously when you can mark it, you are fully traceable as well. So here is the application using a 3D printer, and I can speak to RIZE. Using RIZE, you can actually create these seals at a much lower cost, faster than anyone could deliver to you. I'll talk about another use case. This is quite common. When you are using 3D printers, there's always the tray size and the build volume. And sometimes you might have to create parts that are bigger and that exceed the build volume. Like in this case, here's another actually mold, by the way. And because of Rizium and the special properties that Rizium has, there is a very eco-friendly, you can actually touch this particular material. It comes from citrus plants. It's called D-limonene. And it has some very special properties, and I will talk about it. You can create functional parts. So what you would do is inside your favorite system, you can actually cut the two parts into two in such a way that you have a very high surface contact. Okay, and once you have that, and once you maximize the surface area where these two parts come together, now you can actually take D-limonene part. It's available at many places, and you can actually just brush it on the surface. And here's when the magic happens. What happens is, with D-limonene, it actually is not gluing the parts, it's fusing the parts. Because what happens is the material actually diffuses. So the two Rizium parts, when they come together, there is diffusion going on between the two materials, as well as the D-limonene actually hardening. So you literally have almost like a weld between the two parts. So it's much stronger than glue, a lot more functional, and it will survive many more cycles of use cases and testing. So what does it do? Rizium and D-limonene, as I said, it fuses and it glues together. And the other thing that you can do with D-limonene is sealing and smoothing. So when you take this, here is a part that was printed, and you can see the striations on top because that's what FDM does. But then in the bottom, you see that this was dipped in D-limonene between 20 and 30 seconds. And now you can see the surface extremely smooth. And so if you need to have injection molded surface quality, you can take Rizium or RIZE parts, dip it into D-limonene for 10-15 seconds or less than 10 seconds, take it out, dry it, and you get a perfectly smooth surface finish. And that's another unique part about the RIZE material. So what is RIZE? This one that's inside the product. It's a very high strength model. It's a high-end engineering compound. And you can see the material scale. Here you have PVC, here you have ABS, acrylic, PPU, polycarbonate, and Rizium's one sits above that. It's approved for skin and food contact. This is used by many medical companies because it's safe. It also emits zero VOCs. This is truly a desktop industrial additive manufacturing machine, 3D printing machine, because you get zero VOCs, and that's why these printers are in submarines. It has very negligible moisture uptake, less than 0.01%. It has fantastic thermal expansion properties, very low thermal expansion coefficient, as well as very good dielectric background and specific gravity. What I don't have here, it is one of the best materials you can find for chemical reactivity. It has very low reaction with chemicals, and this is why many of the life sciences companies use it in their functional prototyping as they test different mixes, because it doesn't react with materials and it has very high strength. Now, we have the customers in medical, manufacturing, defense aerospace, as well as for design collaboration. In biomedical, companies are using for preclinical, functional prototyping and custom tooling. For manufacturing, it's being used for end-use parts, functional prototyping and custom tooling as well. We have many aerospace and defense customers that are using for, again, custom and replacement and use parts, whether they're in the theater or in creating different models. And finally, for digital collaboration, we have this Industry 4.0 QR codes, where anybody anywhere in the world can very quickly do a QR scan and figure out exactly where this is used for design review, traceability with metadata, as well as IP protection. I can confidently tell you, RIZE is the only 3D printer in the market where you can actually do full serial control with traceability that has metadata attached, with data coming from PLM ERP systems, with full IP protection of the design prototypes that you have created. And this particular marking is not on the surface, it goes deep. So the only way you can actually remove this IP protection is to destroy the part. So you do this, you're confident, doesn't matter where this part is today, 10 years from now, you know where this part was created, who was actually designed for, where it is used, what the company is for, and all that good information, and tie it with your PLM ERP systems as well. So now your 3D additive manufactured parts are fully traceable inside your entire supply chain. So customers telling about RIZE, you can see that it went from 6 to 8 weeks to $1 to 1 day to $1.25 per part. You can see we have a customer, HMS Industries, where they got the printer in less than 20 minutes they were printing it. We have a global life sciences company which says that the printer is easy and reliable with very little complexity or tech support. Post-processing is minimal, and it's the fastest to get to the final part. We have a customer, Nuance and Facades, that's running it non-stop for many months now with no issues. Life sciences, here you can see they are using 1 to 2 spools of material a week. That's basically 4 to 8 spools a month, and you can see they are printing it all the time. And then you can see a medical design engineer from a CPG company saying they can 3D print an injection molded quality part because of the Z strength. What does it mean to you? At a company PSMI, it is 35x faster, 24x cheaper. HMS, 21x faster, 25x cheaper. Consumer products company, compared to other 3D printers, RIZE is 2x faster and 2x cheaper. And you can see down what people are saying here, 50% saving on material because the material costs are much lower with RIZE. When you buy a 3D printer, you are paying for both the 3D printer and ongoing material usage. And with RIZE, the material costs are quite low. And what this basically means is your total cost of ownership is probably one of the lowest in the industry with industrial quality that can run 24/7 with no issues. So why RIZE? Basically because it is industrial desktop 3D printing for additive manufacturing. It's one touch, simple, speed, and safe. It mimics injection molded parts, strong, with diverse software applications and in all weather conditions because of material and material management. And it is Industry 4.0 ready. You can digitally connect everything you have created throughout your infrastructure, as well as we have partnership with very key Industrial 4.0 players. So it's time. We said it's a 22-minute webinar. We are 1 minute over. So thank you very much for joining. And if you have any questions, I will stay on the line to answer those. Otherwise, have a wonderful day and see you soon.